This is normal distribution. Get Excel going and equals norm. Okay, this is the normal distribution. We did the binomial distribution. The normal distribution is the one with the shape that everybody associates with statistics. All right, this is the normal, and in the middle is the average. You remember the empirical rule? One standard deviation out and down is 68%. And two standard deviations is 95%. Right? That's the estimate. The way that it actually works is with these commands. There's a norm.dist, and it gives you probabilities, or the area covered, from the far left of the normal distribution up to a certain value. So instead of what we've got here, norm.dist gives you the area up to some value that you specify. Right. This one, this is the middle, 95% here, 68% there. If we put in two standard deviations down, whatever this value is, we'd get 2.5%. That's the area in the tail. As you come this way, if you put in one standard deviation down, you get about 16%. So this is the middle. These commands always come from the left. They start at the low end and come up. The norm.inv the norm.inv from the left, if you give it a probability, it tells you what the cutoff is. But it's still from the left. So if I put in 50% in the norm.inv, I get the middle. I get the mean. The norm.s.dist is for the standard normal distribution. And this is where the 1 and 2, minus 1 and minus 2 come from. For the norm.dist, this is any distribution going. Any normal distribution. The norm.s.dist is for a mean of 0 and a standard deviation of 1. And this is what this thing is. This is minus 2 standard deviations, or minus 2, minus 1 standard deviation, 0 standard deviations from the average, plus 1, plus 2. And this is on a z scale. These are z values. And in the normal distribution, everything is measured in standard deviations. So this is a normal 0, 1, which means it's got a mean of 0 and a standard deviation of 1. So if I go 1 down, I get minus 1. This other one is a standard normal converted to actual values. So if this were 50, if the mean is 50, see, I've got a normal, and this is the way it's written. This is a normal distribution with mean 0, standard deviation 1. This is a normal distribution with mean 50, standard deviation 10. So if I go up 1 standard deviation, this is 60. 2 is 70. Minus 1 is 40. And minus 2 is 30. Right. This and this are the same thing. Here I specify how many standard deviations, 1, 2, minus 1, minus 2. Here I actually use the value. And if I take the 40, I want the z-score. This is x on the scale. It's real numbers. I want the z-score for 40. I subtract the mean and divide by the standard deviation. When I do that, I get 40 minus 50 is minus 10, divide it by 10, and I get minus 1. So this here is in that position. Right? The reason we have the standard normal originally was that we only had one table, because every time the mean and the standard deviation changed, you had to have a new table. So if I wanted to know where 40 was, I would standardize it, look it up in the standard normal table, which never changed, and then I can convert it back. So all of these things depend on which way you're looking at it. This way, we're looking at the actual numbers. This way, we're looking at how many standard deviations. So, this is one standard deviation up. It corresponds to that spot. And if I take 60 minus 50, divide by 10, I get plus 1. So, this is a normal distribution. This is standardized. And we still need this one. Before, we had to standardize everything, or we couldn't get anything. Now, I can put this in Excel, I can get anything I want. But the standard normal is still important for translating things, for comparing things. All right, look at this first problem here. Bricks are 7.625 inches long with a standard deviation of 0.2 inches. In a pallet of 1,000 bricks, what percent would be expected to be 7.6 inches or less in length? Pick a spot. We want equals norm dot dist. This is going to give us the area to the left of whatever number we're looking for, and in this one we want 7.6. And this always asks for the value. This is going to be 7.6, the mean, which is 7.625, and the standard deviation. So we've got 7.6 7.625 is the mean. The standard deviation is 0.02. The next one is cumulative. In the binomial, this would be 3 or less. In the normal, we always use the cumulative to get area because we want the area from the left. If we put in 1 and press the button, right, we get way more decimals than we need. This says that basically 11% of the distribution is to the left of 7.6. So here's my setup. I got this shape, and it always helps to draw a picture. This is the middle, 7.625. If I go one standard deviation up, I add the 0.02. If I go one standard deviation down, I subtract 0.02. But here, somewhere in here, and it's pretty far down. If I put in 7.6, that means that this area here is 10.56%, about 11%. Comes from the left. What if I want to know how much is above 7.6? Subtract it from 1. It's the other side. This is just like the binomial, except the binomial, if I said exactly 3, I get an actual probability. If I put in an individual probability for 7.6, not cumulative, all I get is the height of this curve, which is completely useless unless you're graphing this thing. This is the way the norm.dist works. Look at the next one. What percent are going to be between 7.6 and 7.65? And 7.65 is somewhere here. I want to know how much is between them. So I go back to binom.dist, and I'm going to put it above because I'm going to do something else here, equals binom, not binom, norm, N-O-R-M dot norm.dist, and this time I want to put in 7.65. And I have to tell it the mean and the standard deviation again. 7.625, 0.02, and everything we do with area is cumulative. So this 7.625 is in the middle. 7.65 is a little above the middle. And to the left of 7.65 is 89.4% of the distribution. So we've got here, this is 89.4, was it? This is from all the way back here, and the normal distribution goes to minus infinity and plus infinity on the other side. There is no end to it. It's just that the probability of things back here in these tails is so low that we don't need to worry about it. So from all the way back there, minus infinity, up to 7.65 is 89.4% of the distribution. So the area between them, the probability that something is but bigger than 7.6 and less than 7.65 is the difference between these two. So the difference between those two is equals this one, 7.65, minus the 7.6 minus that one. So here, 78.9% of the distribution is between 7.6 and 7.65. And if you draw the picture, this area was 89 whatever. Minus this, to get it, I had to come from this side up to here and get that area, then get this side up to here and get that area and subtract them. The norm dot dist always comes from the left. And there's no command that will give you the other side. Everything has to be done from the left and then subtracted if it's appropriate. The next one is, what is the length of the shortest 85%? This one, we have this same distribution, but now we're going to give it 85% from the left, and it's going to give us a number. INV, you give it a probability, it gives you a number. The dist, D-I-S-T, you give it the number, it gives you the area. So if I want 85%, I use the .INV, and I want 85%. I'm going to do norm .INV. I have a probability. I want the value. 0.85, and I still have to give it the mean and the standard deviation, so it knows what to do. 0.85, 7.625, and 0.02. In this distribution, that mean and that standard deviation, I want to know where 85% is. In this one, this was 7.65, 89%. This one is 85%. It's a little bit less than 7.65. Everything has to come from the left. And any time you have to do one of these and you need to figure it out, draw that picture. In this next one, we got grocery store wait times. So what percent of shoppers wait 6 minutes or less? Average time is 4. Standard deviation is 1.5. What percent wait 6 minutes or less? Which command are you going to use? Norm.dist. You've got a number and you want a probability. You want the percentage. The area is the percent. Norm.dist. First entry is a 6. What do you put in next? It always tells you. 4. Put in the mean. Next. Standard deviation. Next, there is the 1 for cumulative. And I get 91%. So 91% of people wait 6 minutes or less. What percent wait more than 6 minutes? To get the other side, I have to subtract it from the total area, which is 1, or 100. 100 minus 91 gives me 9%. So there's 9% over here, 91% over there. I can't get this side any other way except subtracting. Okay, so if I want anything in here, it's got to be 1 minus whatever gets up to that. What is the shortest wait time for the 25% waiting the longest? What 25% do I want? This is the 25% waiting the longest, so I cut it off here, and I want 25% of the area. What do I have to give the command? Which command, dist or INV? Dist, I give it a number, it gives me an area or a probability. INV, I give it a probability, it gives me a number. So this one is INV. What do I have to put in INV to get this number right there? If I put in 0.25, what's it going to give me? It's going to go here. All it can do is come from here and go up. So what do I have to give .INV to get that number right there? 75, because it can only come from the left. So I'm going to use 0.75 in the INV. Norm.INV 0.75. And for an INV, I never have to give it a cumulative or anything. It assumes cumulative. I've got a mean of 4 and a standard deviation of 1.5. And this number that I want is, what was it, 5.01, 5.01. So 75% is to the left of 5. 25% is more, and that's the 25% I want. But to get it, I've got to come from here. That's the only thing about the commands that you have to remember. It always starts back here and comes up. The average wait time in an emergency room is 52 minutes. In the middle is the mean, 52. Standard deviation is 21. If I go one standard deviation up, 52 plus 21, what is down here? One standard deviation down. 52 minus 21, 31. 68% of the distribution is between here and here. If I want to go 2 standard deviations up and 2 down, I add another 21 in. So 21 plus 73 is 94. 21 subtracted from 31 is 10. This picture is not to scale. What percentage wait more than 60 minutes? Approximately, using the empirical rule, what percentage wait more than 60 minutes? Here's 60, about. What do I know about the area just given the mean and the standard deviation? 68% in here. This is not quite there. What is to the left of 52? 50%. All right, so I know I got 50 here. I'm not quite up to this, so I know it's got to be between 50 and, 84, all the way back. So I've got an estimate. What side do I want? What's it say? More. I want that. To get that, I've got to get this and subtract. So we've got .dist or .inv? Dist. We got a number. We want an area. Equals norm.dist. And these things here's my norm.dist, the .inv. This is going to be the standard normal. We're going to need those eventually. But look here at norm, dist, norm, inv. Those are the old commands, and they are only in there to make sure that the system is backward compatible with previous versions of Excel. That's what these things show up all the time. This is norm dot something. The norm without the dot is a backward compatible command, and you can actually use these, the norm dist. But we're up to date. We got norm.dist. What number is x? 60. Mean and standard deviation. Mean is 52. Standard deviation is 21. And I want cumulative. Anytime I'm doing norm.dist, basically I want cumulative. I want a 1 in there. So I got 64.8, about 65% of the distribution. And where is that? I need, on this one, 1 minus that 0.648, and I get about 35%, which is about right. So from here over, is 35%. All of these things are exactly the same. Where am I? What do I want?